Hello everyone, welcome to Mindspan Education. We have already completed, in last lecture itself, we have already completed the calculus portion of uh, this complete grade DA course as per the syllabus. In this particular video, I'm going to explain what is how we use this calculus in machine learning and some higher order uh, calculus, multivariable calculus that are actually being used in the machine learning and AI. Since as part of the syllabus, they have only mentioned the single variable calculus, but uh, machine learning problems are not single variable most of the time. All the time, you can say they are multivariable. So we'll see some multivariable calculus also. And as per the syllabus, we have already completed all the videos that we have completed are exclusively available at our mindspaneducation.com. There you can go and watch those lessons. And apart from the lessons, we have also given the uh, revision notes, handwritten notes. They are very useful when exam comes near. So that you don't have to watch the lecture, full lecture again and again. And also a lot of practice problem, almost 100 plus practice problems in this calculus only. We have already uploaded at mindspaneducation.com. So you can go here at mindspaneducation.com and you can start solving those practice problem and watch the lecture and also see the revision notes. Okay. Everything will be available at mindspaneducation.com. Few of the videos we have also uploaded at YouTube so that you can get an idea what kind of lecture we are providing. Okay, okay, let's start in this lecture. What we are going to see some higher order calculus, okay, and how we actually correlate it in the machine learning. That's what we are going to focus on today. So it is not part of the syllabus, but you should know when you delve deeper into the machine learning and even in the linear algebra, there you will need all these concepts very much. Okay, so now let's start. Okay, have you ever given a thought how Flipkart recommends you the right product that you might be looking for? Have you ever thought that जो भी हम चाह रहे होते हैं वही एग्जैक्टली मुझे रिकमेंडेशन में मिल जाता है? कभी आपने ऐसा देखा, नोटिस किया? ऐसा होता है हमेशा. Have you ever also wondered how does the linear regression find the best fit? These things are handled by calculus portion of the mathematics. How it is done? If you have already gone through the basic calculus that we have already provided in the lecture, there we have talked about optimization. There we have talked about finding the maximum, minimum, finding the optimizing any particular curve, optimizing a function. Optimizing a function can be anything. It can be a cost function. It can be a profit function. We can error function. In machine learning, particularly, there can be error function. And optimizing the error function means minimizing the error. Okay, optimizing means either minimizing or maximizing. So all these things where we are trying to optimize a particular function, or you can say a particular uh, you can say the technique that we use comes from calculus portion of the mathematics. It also involves other things from probability, from linear algebra, from other part of mathematics, but calculus handles the optimization part of the multivariable functions that we see in machine learning. Okay, so everything in the machine learning, we can, it is safe to say, let me write this, it is safe to say everything is in machine learning in machine learning learning, everything is in some form, it is optimization only. We are always trying to optimize or minimize the error, maximize the probability of best output. Okay, everything is in some way optimization only. Okay, so, or in other word, we can write like this, that a machine learning we can write is equivalent to minimize error. Minimize error. Now, you see, in machine learning, what we do? We fed some training data to a particular model. Model means function. Let me write this. Model means some function. Okay. This is a model. We are feeding some data to it to train it. Okay. And we are getting some output. Okay. This is model means this is function. Now, input is data set. First, we train this model. Training means we try to find the best fitting model for our use case, so that for the existing input and output that we already know, that for input 1 output should be 2, for input 2 output should be 3. Let's say these are input output pairs. For input 3 output should be 4, like this. Suppose we have this data already available, then this data set is called training data. Training data, where we know both the input and the output of the possible output. Okay, we know both of them. So we feed these inputs and try to devise this model, try to uh, make this model in such a way that this remains very close to the output. Either very close means it's ideally it should be exactly 2, 3, 4, whatever output we are getting here, exactly it should be this only. But always when we try to fit a curve, it won't always give you the exact output for all the inputs. Okay, since we are trying to generalize a particular function, let's say x, y, ax plus bxy plus cx cy square. I'm just taking a simple example. Suppose this is our model, okay? This is our function where we are trying to find the value of a, b, and c, and x and y are our inputs. Here we have only one input. We can have 2, 1, 1, like that. These are inputs, okay? We can have multiple inputs. In real world, there will be multiple parameters on which the output will depend, okay? Now, setting the model means devising this model means trying to find these constants, these weights. These are called weights. Okay, these weights, because these are variables which will take the input, and based on these weights, it will try to give you a particular output, right? And that output should not deviate much from this actual output. Okay, if error is 0, then that will be the ideal model. That means it is giving you exactly output what it's supposed to give. Okay, then there will be 0 error. But when you fit this curve, since we are generalizing this model and we are using same machine for all the inputs to get the output, so it won't always give you the exact output. It will give you close output. That means we are trying to fit a curve. Means we are trying to fitting means trying to find a curve, equation of the curve that takes these input and gives you output, these outputs, right? So on this training data, we try to feed this training data and we try to get the exact output, these outputs. And now, why we do this when we already have the input and output? Why we are sweating this much on fitting this model? Because in future, when we get a different input, which we do not have as part of our training data, let's say 2, 4, which we have never seen in the input ever in our life. When we give the input, then it will give you some output, let's say 5.6 something. Then we can say that we have fit a model so that it is probably giving close to the actual output. So if input would be 2 and 4, then output should be close to the 5 and 6, 5.6, right? Like this. So if we get unknown inputs, then what will be the output? Predicting that is the actual work of this model. Okay, that's what whole machine learning is about. So what we try here is we try to minimize error. Error means how much we are deviating from the actual output. If output was, suppose actual it's supposed to be 6, right? Suppose actual output supposed to be 6. Let me change the color. Suppose the actual output was 6 and we got 5.6 based on this training data. We fit a curve, we got this model and we got 5.6. So deviation, how much is the deviation? Deviation is difference. Difference is 0.4, right? This is our error. So we supposed to fit this curve in such a way that this error should be minimum. If it was 0.002, and that means if we had gotten 0.998, 5.998, then that would have been better answer for us, right? This is more close to the actual output. This would have been a better model, which had given us 5.998. Okay, then error would have been very less. So our main goal is to minimize this error. To minimize this error. This is our main goal, right? So whenever minimization, maximization, or optimization comes, since we are talking about the function itself, these are function. Model means multivariable function. So there this calculus comes into picture because calculus teaches us how to optimize a function, how to optimize the output of a function, how to minimize a curve, how to know the actual nature of the curve, whether the curve is going to increase, whether the curve is going to decrease when we increase the input. All these natures, these are given by this calculus portion of the mathematics in this machine learning course. That's why we study mathematics extensively as part of this data science and AI course, right? There are three to, you can say almost 30 to 40% syllabus is uh, taken over by mathematics itself. It is very important to be sound in mathematically to understand the machine learning course. Now, whatever we had studied in as our part of syllabus, that we studied as single variable calculus. Till now, we studied everything like function, single variable function, domain range, limit, continuity, differentiability, everything. But they were for single variable, means we had the function like fx equal to some function ax square plus bx, like that, right? Bx plus c, something like that. We had only one variable. One variable means one independent variable that will take the input. But here, for optimization, what we did, we used to find, suppose, let's take an example. Suppose we have a function x square plus 3x plus 1. Suppose this is our model. In machine learning, we have only single variable model. What kind of model in real life it can happen? Let's say how much you sweat, that depends on how much the temperature of the environment is, right? So only one input, the temperature of the environment. If the outside environment temperature is 40 degree, you will sweat more. right? If it is a 30 degree, you will sweat less, right? That kind of model is this. Okay. Now, there are obviously other factors also, humidity and everything. But here we are taking only one variable model. Okay. Now, for this optimization, what we used to do? We used to calculate f dash x and then equating this to 0 to find the critical points, right? And then based on either first derivative test or second derivative test, based on that we used to find maximum or minimum value of fx. But this was really good. As part of the calculus we studied and we understood, these were relatively easier topic to understand, but life is not that simple. So to complicate this more, our mathematical models are not single variable. Most of the time they have hundreds of parameters, hundreds of variables. Okay, and we have to optimize based on those variables. So let's take an example. So our problem is, a real issue is, let me write this. Our real issue is machine learning is, these were good. These were good boys. Okay. We used to find maximum minimum value and everything is done. But in machine learning, that is not sufficient. Okay. ML is all the most of the ML problem. Let me write this. Most, I should write all, but let's just say most of ML problems are not single variable. Okay, that's the real problem. Single, not single variable. Not, mind this note. Okay, write this in red, that not single variable. They are multivariable. That's why we cannot do the derivative like this, and we cannot find minima maxima the way used to find with the single variable. That's why other higher partial derivatives, gradient and hessian, all these things comes into picture in the calculus. Okay, but those are, we will not discuss those things in deeper manner here. We will give you brief idea what they are and how we use them. Okay, whenever we come in the different part of our during the course, at that time we will delve deeper into those particular topics. Okay, so first, here what we did, you used to do, we used to calculate the derivative. So here we cannot calculate derivative like this. Here we used to calculate, how we calculate partial derivatives. So derivative becomes partial derivative. Partial derivative means we are calculating it partially. Partially means that since there are multiple variables, independent variables, so we at a time we are considering that only one of them are variable and other are constants. That's why it is said that it is a partial derivative. Now, let's say if a function depends on multiple variable, say for now we will take only two variable x and y. Instead of fx, now we have fxy, means there are two inputs, x and y, two independent variables. Okay, then we say that derivative are done with respect to one by considering others as constant, considering variables as constants, right? What does this mean? This means I will give you an example, then you will get the better idea. Okay, example is, let's take a concrete example. If fxy is, let's say, x square plus 3xy plus y square. Suppose we have this two variable function. Okay, now if we are going to calculate this derivative of this f, then we will calculate partially, we will calculate with respect to some function. So we will not write df by dx. Okay, since writing d means you have calculated the complete derivative. Since complete derivative are not readily available at in one go, so we write this with a different symbol. It is called del f by del x, means we are partially calculating the derivative of f with respect to x. That means only x will be considered as a variable in this whole function, and rest everything will be considered as constant. So if x is only the function, then this will become 2x plus y is considered as constant, 3 is also constant. So this will remain 3y, and y square will become 0, right? So del f by del x will become 2x plus 3y. This is also called fx. Okay. Now, similarly, if we calculate in similar way, we calculate del f by del y, then what we will get? 3x, because because of the second term. First term will vanish since x becomes constant, and this will become 2y. This is called fy. In other way, we can write fy also, del f by del y or fy, both are fine. Similarly, when you go on for the second order derivative, then that we will discuss later in this lesson. Okay, so this is how we calculate the derivatives of a multivariable calculus. We calculate partial derivatives with respect to x, then others are constant. With respect to y, then except y, everything are constant, considered as constant, and we calculate the differentiation as usual. Okay, by considering these restriction as described above. Okay, now uh, real what is the interpretation? Why we are calculating this partially? What does this really mean in terms of machine learning? It means we are trying to find what we are trying to calculate by calculating this partial derivative, trying to see the change in output with respect to change in one input variable, or you can say independent variable. Okay, variable, by keeping keeping others constant. That means we are only changing one input and we are keeping the others as same all the time, and we are trying to figure out what is the change in the output based on this particular inputs change, right? And this is exactly is called training. That's how we train. This is called training of a model, right? This is called training the model, right? We are training the model based on our inputs. So when we calculate del f by del x, that means we are trying to find the output, how output is fluctuating based on if we change the input only x input, if we change only first input, if we change and we keep the second input that is y as constant, then we try to observe the fluctuation in the output. That's what this partial derivative means. Okay, and this is called training. Training means we are training the model based on changing the input and observing the output. Okay, now so this is basically what is called this is how we calculate the derivative, higher order derivatives. What I mean to say is this is how we calculate the derivatives of multivariable calculus. If there were more variables, then we would have calculated like this one. Okay. Now let's talk about one more concept that is called gradient. These are very important concept in machine learning, and they are very closely correlated related to calculus. Now, it is what is gradient? In simple term, it is collection of partial derivatives. Okay, when we collect this partial derivative, it is called gradient. As simple as it is. All these partial derivatives. All these means if we have multiple variables, suppose here we had two variables, means we will get two partial derivatives for first order, right? Now it is written like this: del f, that is gradient, and here we write del f by del x, del f by del y, del f by del z, like that, and other if there was any more variables. Okay, all the partial derivative. These are when they are collected, then it is called gradient. It is written in the vector form. That means uh, all the independent variable are considered as a dimension. In that particular direction, how much function is changing. That is what it is called uh, saying. Okay, so if we write this in vector form, that is I cap del f by del x I cap plus del f by del y j cap, all this thing, then this will become actual gradient vector. Okay, now let me give you an example. Suppose if for the same function, if we had, I will take the same example everywhere so that you can correlate properly. Okay. Now, if we were to write the gradient for this, then what we will do? First, we will calculate fx, which is 2x plus 3y. Then we will calculate fy, which is 3x plus 2y. And then gradient vector will become in the matrix form. If we write, first we will write fx and then fy, right? So this will become 2x plus 3y and then 3x plus 2y. In matrix, writing matrix form, that means uh, we have more than one variable. Okay, we can use this in different forms. When we write in vector form, then we can do vector multiplication, all these cross product and dot products, everything we can apply here. Okay. Now, so what gradient, why we calculate the gradient? Since for the single variable, the concepts were very easy and it was very easy to correlate and intuitive. But for the multivariable calculus, it is relatively difficult to uh, feel the change and feel these formulas. Okay, so now this is not a line or a function. This is actually, you can say, when you take two variable, then it becomes a plane. It does not become a line. It is a plane now. Now in the plane, if there is a you can say ball, or there is a heel in plane, you can have ball means गड्ढा है, और या तो कहीं ऊंचा हुआ है, हील है, तो वो कैसे हम पता लगाएंगे? उसके लिए ग्रेडियंट फैक्टर का यूज किया जाता है। तो ग्रेडियंट फैक्टर हमें क्या बताता है? तो मल्टी वेरिएबल जो होते हैं, जितने भी आप वेरिएबल बढ़ाते जाओगे, ये उतना ही कॉम्प्लिकेटेड बनते जाएगा डायमेंशन वाइज। थ्री डायमेंशन के बाद तो उसको महसूस कर पाना बहुत ही मुश्किल होगा, सिंस वी आर यूज टू सी एवरीथिंग एट मैक्स थ्री डायमेंशन, सो इट इज difficult to intuitively understand. So in two dimension, in one dimension, they are simply turf and crest, right? यहाँ पे ऊंचा है, यहाँ नीचे है, ऐसे सिंपल टू डायमेंशन में होते हैं। बट थ्री डायमेंशन में वो यदि हम दो वेरिएबल लेते हैं इनपुट, तो ये एक प्लेन बन जाता है, ये एक नॉर्मल कर्व नहीं रह जाता, ये एक प्लेन बन जाता है। और प्लेन में क्या होता है, गड्ढा हो सकता है, कहीं पे आप देखे होंगे प्लेन जमीन है, वहां पे कहीं गड्ढा है, तो वो बॉल कहते हैं उसको। कहीं पे ऊंचा है जमीन, तो वो हिल है। तो ये ऊंचा, गड्ढा, ये सब जो चेंजेस हैं प्लेन में, वो होता है। ये हम, आई एम जस्ट टॉकिंग इट with respect to two variables. If you go for three variable, there will be different story again. Okay. Now, so what this gradient says, this gradient says, gradient tells us why we calculate gradient, tells us about fastest direction of increase. Increase. That means, ये तो ऑलरेडी मैंने बताया कि ये एक वेक्टर फॉर्म है, ये एक डायरेक्शन बताता है किस डायरेक्शन में कितना चेंज है, किस डायरेक्शन में कितना चेंज है। तो ग्रेडियंट वेक्टर हमें बताता है कि किस डायरेक्शन में हमें, ये ग्रेडियंट वेक्टर के डायरेक्शन में हम जाएंगे तो हमें सबसे ज्यादा चेंज मिलेगा, सबसे ज्यादा इंक्रीज मिलेगा। तो जो डेल एफ होता है, वो हमें बताता है फास्टेस्ट किस डायरेक्शन में इंक्रीज होगा। इसी का निगेटिव डेल एफ ले लेंगे तो वो बताएगा फास्टेस्ट किस डायरेक्शन में डिक्रीज होगा, राइट? ये इंक्रीज बताता है, फास्टेस्ट इंक्रीज किस डायरेक्शन में होगा, फंक्शन का वैल्यू ओवरऑल। ओके, ये बताइए कि फास्टेस्ट किस डायरेक्शन में डिक्रीज होगा फंक्शन। तो अब यदि हमें मल्टी वेरिएबल कैलकुलस है, तो उसमें हम कैसे कोरिलेट करेंगे इसको? हम ग्रेडियंट वेक्टर निकालेंगे, और यदि वो मेरा एरर फंक्शन है और मल्टी वेरिएबल है, तो उसको हमें मिनिमाइज करने के लिए हमको ग्रेडियंट का निगेटिव डायरेक्शन में मूव करना पड़ेगा। ग्रेडियंट निकालेंगे और ग्रेडियंट के निगेटिव डायरेक्शन में जो भी वेरिएबल को चेंज करने, एडजस्ट करने से हमें ले जाएगा, हम उसी डायरेक्शन में बढ़ेंगे, तो एरर हमारा फास्टेस्ट रिड्यूस होगा उसी डायरेक्शन में। आप समझ पा रहे हो ये कैसे कोरिलेट हो रहा है मशीन लर्निंग के साथ? ओके, तो ये हमें बताता है कि कैसे चेंज होता है। आपको एक रियल लाइफ मशीन लर्निंग का एल्गोरिथम बताता हूँ। एक होता है ग्रेडियंट डिसेंट नाम का, ग्रेडियंट डिसेंट एल्गोरिथम होता है। ये एग्जैक्टली इसी टेक्निक पे काम करता है। इसमें क्या होता है कि हम थीटा न्यू जो होता है, एग्जैक्ट आपको इक्वेशन पहले लिख देता हूँ। ये जो ग्रेडियंट डिसेंट है वो है क्या? ये बोलता है कि थीटा न्यू जो है थीटा ओल्ड माइनस ईटा इंटू डेल एफ होता है, इसका ये मतलब है। ओके, तो इसमें इन सब का मतलब क्या है पहले मैं आपको समझाता हूँ, देन यू विल बी एबल टू कोरिलेट प्रॉपर्ली। ओके, लेट मी जस्ट फिक्स दिस। Okay, all right. Now here theta is, what is theta? Theta is parameters. Whatever parameters we have, parameter means input. Okay, parameters, and new means the we are taking different theta. Okay, parameters means the weights that we discussed just now, not the inputs exactly, the actual coefficients of the model, the function. Okay, and eta is learning rate. Okay, I will not go in detail for all these things since they are part of the machine learning. We will discuss in very detailed manner in the machine learning. Here I am just giving you why calculus is important in the machine learning. Okay, correlation, learning rate, and this our hero, this gradient vector is gradient. Okay, so see here negative gradient we are getting. So gradient descent, we are descending in the opposite direction of the gradient so that our error should be should reduce as quickly as possible. Okay, we adjust the theta anyway in the direction of this negative gradient so that our error reduces as quickly as possible. This is real machine learning algorithm which uses directly this multivariable calculus gradient approach. Okay, now let's talk about one more thing. First, I talked about finding the derivative, right? Means I just calculated partial derivatives, right? Of first order, I just calculated first order. In single variable calculus, you might have seen, right? dy by dx, and then d square y dx square, second order, right? This is first order, and like this in single variable, right? In multivariable calculus, similarly, we calculate higher order partial derivatives also. Higher order derivatives also we calculate here. And how we do that? We do that like this. Let's take the same example, okay? Same example we will take so that we remain consistent throughout this lecture. X square plus 3xy plus y square. This was our multivariable function, okay? So first we calculated first order fx which was 2x plus 3y, right? Then we calculated fy which was 3x plus 2y, right? Now we have to calculate one more thing, fxx. This is second order derivative of this fx. Means we are going to calculate another partial derivative of this function. Now this is not the our target function. This is our target function. Here we are going to apply the partial derivative. Here also we will apply the same technique, that if we are calculating with respect to x, that means other we have to keep as constant, right? That means only x will be considered as real variable and y every other thing will be considered as constant. So this will become 0, right? So only we will get 2. Similarly, if we calculate fxy, means for the same fx, we are going to calculate the partial derivative, higher order, second order partial derivative with respect to y for the same function, fxy, okay, for the same function. Then we will get 3. Since this is our fx and we are going to partially uh, uh, differentiate with respect to y, then x will become the constant, right? So this will 2x will vanish and we will get only 3, right? Similarly, if we calculate fyx, means first we have to take fy and then calculate the partial derivative with respect to x, right? Then how we will do that? We'll do that like this. Fyx means this function. So x is the real hero and everything is constant. So we will get 3. And fyy, y is the real hero, everything is constant, means 2, right? Now here you can see these are our higher order, second order partial derivatives. Let me write here again. Fxx is 2, fxy as 3, fyx as 3, and fyy as 2. These are the higher second order derivative that we get. If we go for third order, everything will become 0 since everything is constant now. Okay. Now, what you can observe here, that in most of the cases you will observe that fxy will become fyx. They will be most of the time equal. This is called Claret equation. You might have heard this Claret theorem. Okay, as per the Claret theorem, that fxy becomes fyx provided under continuity condition, that these things are continuous. I will not go deeper in this thing right now, since this is, I'm just giving you a brief idea. Okay, so as per the Claret theorem, under the continuity condition, fxy becomes fyx. Here we have that as equal 3 and 3. Okay, now since we calculated the higher order derivative, using this we have another concept. Using first order derivative we had gradient, right? Using second order derivative we have another concept, it is called hessian. Okay, hessian matrix. Now what is this hessian matrix? This is matrix of second order partial derivatives. Now you see, we are correlating everything as we are delving from calculus to machine learning, right? And meantime, you will see more detail about these Hessians and gradient vector Hessian matrix in linear algebra and probability section, because they uses these concepts more often. Okay, and of course in the machine learning, since that is the real final goal for us. So when we calculate the matrix of the second order partial derivative, it is called Hessian matrix. Now, if we try to calculate the Hessian matrix for this, so how we will write this? If we write Hessian matrix, then we have to write fx, x, fxy, fyx, fyy, right? All these second order derivative will come here. So these numbers were exactly 2, 3, 3, 2, right? So Hessian matrix for this particular function will become 2, 3, 3, 2. This one. Okay. Now, why we calculate this Hessian matrix? That also we will discuss here. So that we should know what is this and why we do this. First, gradient says where to move, in which direction, right? In which direction you will maximize or minimize the error or cost or profit. Okay. Where to move. It gives us direction. Where? But Hessian says the shape of the surface. Hessian says the shape of the surface. The surface. Shape means since it is a surface now. If we are talking about two inputs, means plane. It's a plane, not a curve. So it is a surface now. Like, for example, whether it is a ball that we talk about, whether it is a ball, it is a hill, or it is a straddle point, saddle point. Okay, these informations are derived from this Hessian concept. Okay, now this decides. So this we can say that this decides local maxima, minima, or a saddle point. Saddle point means there is no maximum or minima here. Okay, saddle point. In the curve, you cannot get those nice looking in the surface. You cannot get those nice looking curve, and by looking, you can just say intuitively that this is the minima. But you get a surface. That surface is bending somewhere downwards, somewhere bending upwards to form the ball and heel. And sometimes it bends, but it goes on downwards. It just remains there for some time and then again start going downward. So this forms the saddle point. All these things, right? So this Hessian also we talked about. I'm just giving you brief idea, okay, so that you can correlate why this calculus is so much important in this machine learning course, okay? And everything you can easily correlate if you have already gone through all the 18-20 lecture that I have already uh, given on this calculus subject already given. Okay, now there are some differential operators that we use. Okay, some operators like that we use to calculate in this machine learning. Okay, first we had gradient, right? Gradient is also an operator. Okay, we apply this gradient operator. Okay, now this changes a scalar into vector. Since gradient is a direction, so it changes a scalar into a vector. Since it will give you, since the function itself was just an output, a scalar value, and when we applied the gradient, then we calculated different direction, different partial derivative, means different dimension. In different dimension, we calculated the change. That means we got uh, values in different direction. That is I, j, k, and based on which variable we used, right? Del f by del x means in the x direction. Del f by del y means y direction. Del f by del z means z direction. So gradient is operator which change a scalar into vector, and it is used in optimization. You have already seen that gradient descent algorithm, right? Used in optimization. Similarly, there is one more that called divergence. This divergence, what it does? It calculates the dot product with the a vector, right? With a vector, dot product with a vector. If you calculate the dot product with a vector, this is the set of the partial derivatives. Okay, means del by del x. This del, let me define this del first, okay, so that you don't get confused. See, del is del by del x plus del by del y in different direction. Suppose I cap, j cap, del by del z, k cap, like this. Okay. When you calculate this dot, obviously this will convert a vector into a scalar, a number. Okay. And this is used in mostly the physics and advanced machine learning. Used in physics plus advanced machine learning. Okay. Similarly, there is another operator. This is called curl. I'm giving you just introductory brief of these wordings so that somewhere it is related to our calculus and they are being used in machine learning extensively. This is a cross product with a vector. That means it will convert a vector into different vector, right? And it is mainly used in vector calculus. Okay. Now, see, in this lecture, what my intention was that to give you an idea, some other topic of the calculus, which is not exactly part of the syllabus that is given by the GATE, but they are part of the calculus and it is used in later part of the subject like machine learning and other mathematics course. So I wanted to give you brief introduction about those uh, calculus part. Okay, so let's just keep this much only in this final lecture, you can say, and everything you can watch all the lecture and everything available at mindspaneducation.com. There you will have a practice problem and linear algebra is also going on. Machine learning is completed. Sorry, calculus is completed. Uh, Probably I will take next subject, maybe data structure or DBMS. Let's see, and then I will finish that in given timeline. All the timelines loosely given on the dashboard. So once you log in, you will get all the details available on your student dashboard. So just go to mindspaneducation.com and explore all these courses and take the maximum benefit out of all these materials available. Okay. Thank you everyone. Happy learning. Keep practicing.